Good evening, Hemant.
Good evening, ma'am.
Okay, fine. So it's audible, right? Okay.
Yes, ma'am.
So you were able to solve the graded questions for week 10? The deadline
Ye-
is day after tomorrow, right? Did you try
Yes, ma'am. Yes,
solving
ma'am.
those? Are you able to do it?
Still not completed yet, ma'am.
Okay, are you able to try it out?
Actually, I haven't practiced, ma'am.
Okay, fine.
I will do today, ma'am.
Okay. Okay, so any question in the graded, I mean, something like that we had seen in the practice needs to be updated as such that you can find out from your side for week 10 or week 11. Let me just check once again tonight because you have the deadline on Wednesday, right? So I will just recheck anything on week 10 and 11 graded question. Anything needs to be updated or somewhat. I'll just check from my side also. Sir, I'm not able to hear you.
Yeah, so I don't have a question as such on week 10 or 11, but I understand in our in our quiz too, the question set on Laplace transform that was not considered for grading.
Yes.
So can we still get to know how to approach the solution for that problem and maybe get to solve it? That will help us understand the mechanism of
Which one? That question which was removed, the solution for that you are asking.
yes.
Yeah, you means the that partial fraction method.
Yes, it's means that's understood that we'll have to do partial fraction for it.
Okay.
But the issue that I faced was that the polynomial is a degree 4 polynomial that I was getting, and the solution expected, means at least to me, it looks like it should have been a degree 3 polynomial.
Yeah, we will sometime take that and discuss. We have revision sessions coming, right? So sometime we can take that question and do that.
Okay, yeah, thank you.
Okay, so today we can just discuss the week 11 topics and few practice questions as possible to be solved today. And then tomorrow also I'm planning one session from 7 to 9. You will get the notification message or mail. So tomorrow we will have another session on week 11, 7 to 9, so that before Wednesday we can wind up with week 11 with today's and tomorrow's session. Because you have week 11 deadline also on Wednesday, right? Week 10 and week 11 together.
Yes, ma'am.
Let me share my screen.
This is the first session we are having on week 11, right?
Yes, today's is the first on week 11. Tomorrow, so today possibly we will be discussing mostly the two-port network parameters and some numerical problems on that from the practice. And maybe tomorrow we can discuss that transformer and the questions based on that also. So that with that we will be winding up by tomorrow's session, week 11 topics as a whole.
Okay.
So that what I plan to do is this Thursday also we will have this week. So that will be on week 12 session 1. So the next Monday we will complete with week 12 with the session 2 of week 12. So that after that, in just like this week that I take tomorrow's session, I plan to take every Tuesday 7 to 9 till your end semester exam. So in addition to Monday and Thursday, I will be taking Tuesday as well. So that schedule I will update with you sometime later. We can plan the revision sessions accordingly. First, we will cover the concepts in the corresponding weeks, then the numericals, Then the extra tutorial questions or practice questions you were some of you were requesting from diodes, transistors, etc. also can be considered during that time. Um, then rest you also should have to work from your side so that you find it easier.
Sure, ma'am. Yeah. Thank you. We'll put in required efforts.
So we start with the discussion on two-port networks in the week 11. So basically what has been, hope you would have gone through the lectures of week 11.
Not all of them.
Okay,
The last three lectures, which are there on diode, BJT, and MOSFETs,
are it to be reviewed?
I'm yet to go through
Yeah,
those
that's
sessions.
fine. That is
Those
just
lectures.
a go through on what has already been discussed in the corresponding weeks on diodes, and that means just a revision of something like that, a summary on those topics. That is fine. I hope the key topics of the week, that's the two-port network parameters and the what transformer as a two-port network. Hope that you would have gone through.
Yeah, went through those lectures. I'm not sure if I means yeah, this session means a discussion with you will certainly help in clarifying doubts and a better understanding of the topics there.
Fine. Hemant, have you gone through?
No, ma'am. Two-port network, ma'am, I studied earlier, ma'am.
Fine.
But
So
lecture
somewhat you
videos,
have an idea.
yes, ma'am. But lecture videos I haven't seen not.
Which one?
Present lecture videos I haven't gone through, but two-port network I have studied earlier sometime.
Okay, fine.
Ma'am, I just one input or a comment.
Yeah.
While I was going through some material on in the book on BGTs and MOSFETs,
Okay, sir.
I'm talking about a book by Sadra and Smith book.
Okay.
So that has some means equivalent circuit representation of BGTs and MOSFETs like H
I
parameter or
mean,
something.
yeah, that small signal equivalent, right?
Yeah, yeah.
Yeah, we
And
haven't
I
gone through
think
those things as such. So those,
yeah,
as of now, in this course, we may not be going into those that small signal equivalent what you're talking about. I understand, but
yeah,
we have just seen the key things. Say for example, we had just seen the, I mean, transconductance, then the small signal voltage gain, then how to vary that bias point or operating point by choosing a different value for the RC resistor, I mean collector resistor RC, RE, then voltage divided by SR1, R2, all those things. So the main things how what to analyze in the corresponding circuit, whether it be BJT or MOSFET, that we have seen. And even if you see if the case of CMOS inverter, uh, the proper function of the CMOS inverter is what is being discussed in the lecture. not say for example corresponding what the regions of operation those two transistors M1 M2 are in, so that we haven't derived even the corresponding equations also. So like that, what you were pointing out, you will definitely see the in any standard textbook the small signal equivalent, like depend in terms of dependent source, you try to connect it on the other side, right? So all those things we haven't as such seen, but what all that through the depth what we have seen through the lectures, that will be sufficient.
Okay.
Because compared to the I mean, as you already know, the usual BTech degree, that syllabus varies from this because this is fine tuned for the particular requirements, mixed up with, it's a hybrid of even the other students who take up the other degree, the usual degree, what they learn in the second year or something like that, the part of it you may learn it in advance in your first year, something like that. All those things happen, and this is mixed up with the industrial aspects also. So as such, if it was in the other course, regular course, definitely in this paper where you learn this paper, you will be learning these things also, the one which you were pointing out, but not as such in our course.
Okay, ma'am. So is the timing also different? Like we are getting to see these concepts in the first year itself, whereas in regular BTech or B engineering course, they come up or appear later
No, no,
in
no.
the degree?
It cannot be generalized. What I am telling is, say for example, the regular students, they will be devoting much time on, say, another thing to point out is current mirror and current source. There are variations. Okay, I mean, there are something called Whittler current source, Wilson current source, etc. We talk about the drawback in one design, how it get rectified by some means in the that will build up a new circuit with a new name referred as. All those things they will learn when you say for example they are learning current mirror, means they will have all those things in detail, etc. So but we haven't seen, we have in most of the concepts we all these things, say for example even the diode circuits, rectifier also, there are so many parameters like PIV, all those things, but we have just introduced to you only the average value and the basic functioning of the half wave and full wave rectifier, but they will be seeing in addition other parameters also, ripple factor, peak inverse voltage, the derivation of all those things. So that basically differs from their syllabus and ours. Ours is fine tuned for the basic, the key particular requirements. Because it is mixed up with the industrial aspects also. When you step further into higher semesters, you will be able to understand that the faculty coming in are they will be having industrial experience, and the things presented to you will have much more practical aspects also. So what you right now pointed out, for your understanding, if you, and just like Hemant has pointed out, he already knows some idea on two-port networks. Basically, you will also be familiar with many of the things already we have learned through the lectures. So if those things are comfortable for you, you can definitely go through those small signal equivalents also for your more understanding, clarity. Other than that, in depth we may not be covering in our course as such.
Okay, ma'am. Thank you.
Okay. So I have drawn here a passive network, and I have drawn the two-port network. That means we have 4 terminals and 2 ports. This A and B are 2 terminals forming the port 1, and C and D terminals forming the port 2. So this is as such a 2-port network, 4 terminal 2-port network. So far we have seen the 1-port network. So say for example, as all just discussed in the lecture, say we in the while say suppose if we need more amplification factor, we may have multi stages of this amplifier. That means we cascade one stage, one output to the input of the next stage, and so on. So there and all, when it's a cascade of what more than one block, we may have to analyze it in a better manner. How say for example, consider one functional block. What is the input fed to that block, then what is the output, then that output will be fed as input to the next stage, and so on. So we will be basically analyzing by me with the help of this 2-port parameters in those cases. So how to basically do that. So far, what we have seen in the case of single port network, say for example, if we want to even in the corresponding weeks, also we have solved sufficient numericals on. Say for example, if we are concerned in the current flowing through a load resistor or something like that, we will be just abstracting out the corresponding network connected to the load by means of this Thevenin equivalent or Norton equivalent, and then we find out the what is being concerned in connection related to the load, that we find out the current flowing through the load or the power associated with that, all such things. So we basically make use of this Thevenin, finding out the Thevenin resistance and Thevenin voltage, or the Norton equivalent of that network, and then once abstracting it out in terms of those Thevenin or Norton, we will find out the related things in connection to the load. So similarly here also, in case of 2-port network, what we do is here we can just apply basic parameters are the voltage and current. So if I refer the A and B as this port 1, C and D terminals as the port 2, so I may apply between the terminals A and B a voltage being applied. So that is, say example, I am referring it as V1, and between the terminals C and D, I am applying voltage V2. Then with V1 being applied between across the terminals A and B, I have a current I1 set up in the port 1, this side. Similarly, with voltage V2 applied across this terminal C and D, I have a current I2 set up this side. So, and one more thing, again, I'm just trying to go through as it is being discussed in the lecture. That means you know that with this V1 being applied, you have the current I1, and I1, if it enters into this from the port, enters into the network, then once it traverses through this, it has to, the same amount of current I1 has to come out. That means here KCL, there is no charge accumulation. Similarly here with V2 being applied, the I2 enters, I mean it will be inwards, and again it come outwards. Okay, that ensuring that there is no charge accumulation. So the various possibilities of doing is, we can one possibility is just now what has been explained, that across AB we apply V1, and across C and D we apply voltage V2, and we try to measure the currents I1 and I2 accordingly set up by means of this V1 and V2. Or you have V1 I1, then you measure V2 I2, and so on. So those various possibilities or combinations will lead to the various 2-port parameters, the two of which fundamentally has been presented in the lecture, that is your Z or impedance parameters of the 2-port network, and the admittance or the Y parameters of the 2-port network. Other than that, you have this ABCD parameters referred as the transmission parameters, then the inverse ABCD or the inverse transmission, then hybrid G, or all those possibilities are there. So fundamentally we would be learning the Z and the admittance parameters, that is Z and Y parameters. Okay, so while discussing the Y parameters of the 2-port network, what we do is, set enough. So as discussed, V1 is applied across this, and we have I1 being set up, I2. So for measuring I1, we would be finding it as a function of the applied voltages V1 and V2. Similarly, I2, it will be a function of another function, let us take. So F means we can so we basically find out the relations as we get these relations as linear because we have considered for analysis the network to be passive. So we get linear equations connecting this I1, V1, V2, I2, etc. So I1 will be this admittance parameter. Admittance, you know, it is I by V ratio. So function of V1 plus here also we have an admittance V2. So since it is between I1 and V1, we have labeled it as Y subscript 1 1. Similarly I1 and V2, so it is Y subscript 1 2. Similarly here I2 as Y21, and here it is Y22. So if you write it as a matrix, you will get it as I1, I2. This will be the Y parameter, the Y matrix. So Y11, Y12, Y21, Y22. So this is the what, row 1 column 1. So Y11, I1, V1. This is I1, V2. So Y12. So the first row, second column, and second row, first column, and second row, second column. So this is the Y parameters, Y matrix into V1, V2. So I matrix will be the Y matrix into the voltage matrix. So these are the admittance parameters. Similarly, if you do the other way out, you will have the definition of the set parameters. So there we write V1 is a function of I1 and I2, and V2 is a function of I1 and I2. So we write V1 as some so how do I label this? Set this one. Just like here we have seen Y11. How can I label this?
Z11, ma'am.
It is between V1 and I1. So this will be Z11. Similarly V1 and I2. So that will be Z12. Then
Z21,
Z21,
Z2.
Z22. So similarly here again writing this also in matrix form. So here this will be the voltage matrix. Set parameters of the network. How do you want to go about this? Shall we just try to do some problems on this set parameters and Y parameters, and then we move on to the discussion on the transformer, so that that can be together clubbed with the corresponding numerical problems on the transformer, that mutual inductance, all those things. Fine?
Yes, ma'am. Ma'am, here also V equal to Z into I, ma'am.
Huh. Okay. So,
Ma'am, could you please explain how, what is the process, how we have written the equations for V1 and V2 here, and also in the previously I1 and I2, ma'am?
1 second.
The technique, maybe.
What you are asking?
In the previous section for I1 and I2, how we have written the formula?
This one.
I1 and I2, yes.
No, no. In here,
Y11.
here in this, while analyzing the Y parameters, what we basically do is we had applied this voltage V1 and V2, and we are measuring I1 and I2. Okay, so we just before discussed that to analyze the two-port network, since you have here two ports, that is this A and B refers to the port 1, and the terminal C and D refers to port 2. So accordingly, you will have V1, I1, V2, I2. So you have between these four variables, you may have so many combinations. You can apply V1 and V2, measure I1 and I2, then V1, I1, V1, I2, then I1, V2 you find out. Something like that. Those different combinations only I told you will lead to the definition of those new set of parameters. That's what I just before mentioned. You have, in addition to set parameters and Y parameters, you have what are called as ABCD parameters, or the transmission parameters. Then you have inverse ABCD parameters, then hybrid, G, all those things. But we have restricted so far to the understanding or learning of, because if we know this one set of parameters, there are relations connecting these parameters to the other. So we can find out with one set the other set of parameters. If we know set matrix, we can find out the Y matrix. Similarly, we can find out the ABCD matrix, all those things. But so far through the lectures, what we mainly understand is the set parameter, Y parameter, and the relation connecting them. If you had gone through the lectures, you would have learned, you would have seen that while solving the numerical problems, that relation between the two also been mentioned. Okay, that means the relation connecting the Z and Y. So now, while analyzing the Y parameters, that is the admittance parameters, we apply voltage V1 at port 1 and apply V2 at port 2, and with this voltage V1 being applied across the terminals A and B at port 1, we have a current I1 setup here, and similarly here I2 in this side. Okay, so what we apply or what we know basically is the voltages V1 and V2, and with that we are trying to measure I1 and I2. So I1 will be a function, that is what here being written towards this side. I1 will be a function of that V1 and V2, and that relation connecting that what we get will be obviously linear, because the network that we are considering here for analysis is only consisting of components like R, L, C, or any other but only the passive elements. So I1 will be a function of V1 and V2. I2 will be another function. So it has been taken as G to represent a different function of V1 and V2. So if you try to solve it and find out, you will get a relation something like this. I1 is some admittance, that means I by V, that is your admittance. V by I means you will have it as resistance, or if you go with L and C, you will call it as impedance, that we have already seen. So here it is I by V ratio, so it is called as the uh, Y parameter, admittance. So some admittance into V1 you will get, plus again some admittance into V2. So that admittance, since here for the first thing here, since it is connecting I1 and V1, we have simply labeled it as Y subscript 1 1. Similarly, the second thing, it is connecting I1 and V2, so we have written it as Y12, and similarly the other Y21 and Y22. And in the case of second thing, what we do is we apply current I1 and I2, and with I1 current being what applied here, we try to measure the voltage across the terminals A and B, which is V1. Similarly, I2 towards this side being applied, and we try to measure the voltage V2 across the terminal C and D, and with that we define the set parameters. So what we get is V1 is a function. That function here we are representing to just to distinguish from the previous case. Here it is written taken as f prime of I1 and I2. Again, it will be a linear relation. V2 g prime of I1 I2. That means a function of I1 I2. So here, similar to the previous thing between V1 and I1, so we label that as Z11, Z12, Z21, and Z22. Exactly how to find out these parameters Y11, Y12, Y21, Y22, and similarly Z11, Z12, Z21, Z22. We will try to now do it through the numericals. Okay, fine.
Yes.
So exactly whether we want to go by means of a Thevenin equivalent or Norton equivalent, or what type of what thing we are analyzing, we may choose the some what, whether we apply V1 and V2 and measure I1 and I2, or whether we apply I1 and I2 and try to measure V1 and V2, or some other corresponding to that A, B, C, D, or whatever that we do. That depends on the circuit that we are going to analyze, and whichever is convenient or easier for the analysis of that particular case, we may go with that. Okay, and fundamentally, as already being discussed, knowing any one set of parameters, we can calculate by means of the relation connecting the with the other parameters, we can directly find out the other parameters. Okay, so now we I will just pick the problems from the practice assignment where we try to find out the Z and Y parameters. First question. I think it's question 1, 2, 3, 4. Okay, 1 to 4. So this is port 1, this is port 2. So let me mark it as A1 1 dash 2 2 dash. So this is V2 and I2. You're asked to find out the set parameters. So here the set parameter what we have is we want to find out the relation connecting, find the expressions for V1 and V2 in terms of I1 and I2. So what we want is V1, V2, the Z matrix is Z11, Z12, Z21, Z22. One second. Yeah. So Z11, Z12, Z21, Z22, I1, I2. So how can we write here? We have here current I1, and here we have a dependent source to I1, and at from this side here we have I2. So if you remember what has been discussed, if that voltage V1 being applied, a current I1 is set up. So if that has to that enters the network, that will traverse to the network and it has to come back. No accumulation of charge. We discussed right now. So with that in mind, how can I write the current flowing through 10 ohm in terms of this I1 and I2? Or you start from this node. At this node, okay, this node, the current I2 is entering the node and the current 2 I1 is leaving the node. So what will be the current flowing through 3 ohm?
It's I2 minus 2I1.
I2 minus 2 I1. So this will be I2 minus 2 I1. Similarly, at this node, I1 enters and I2 minus 2 I1 enters. So what will be the current flowing through 10 ohm?
I2 minus I1.
I2 minus I1, no. Both of them are entering. So you have to add them up, right? They sum up at this
No, no.
node and flow.
After adding I2 minus I1, ma'am.
After adding I2 minus I1.
I2 minus 2 I1 plus I1. That means I2 minus I1.
Okay, and what about this 2I1? This is also entering,
Yes, yes,
right?
yes, ma'am. Yes, ma'am.
So I2 minus I1, you added only these two. You have to add that I2 minus I1 with this 2I1. So that will becomes I2 plus I1, right? Correct?
Yes, ma'am. So final answer is I2 plus I1.
So what is the direction it flows? Downwards. So I2 plus I1 through 10 ohm flowing downwards. I2 minus 2I1 flowing towards left side through the 3 ohm. So with this, if you apply KVL in the input loop, what do you get? So if I consider this is code, so let me name for your understanding node X and node Y. So later, if you refer, I am for that purpose, for a learning purpose, I am writing here. So at node X, what do you have? Or first we have to write the node Y, then only we can come to node X. So at node Y, what do you have? I2 entering and 2I1 is leaving. So by KCL at Y, I2 minus 2I1 flows through 3 ohm. Direction as shown. Similarly at node X, node X, what do you have? I1 currents, I1, then I2 minus 2I1 and the dependent source 2I1 all are entering. So by KCL, I1 plus I2 will flow through what is the resistor there? 10 ohm.
10 ohm.
Now apply KVL to the input loop. What do you get? Input loop is this one. This one, let me mark it for you. So what do you get? What do you get? Applying KVL.
Ma'am, is V1 equal to 10 into I1, I2 plus I1.
Correct. So V1 equal to V1 is nothing but the voltage across 10 ohm. So that will be that resistor into the current. Current just now we have found it out as I1 plus I2 flowing through the 10 ohm. So that will be simply V1 equal to 10 into I1 plus I2. Similarly, how can you write the expression for V2 by means of KVL? V2 will be the sum of the voltage across 3 ohm and the 10 ohm. 3 ohm it will be 3 into I2 minus 2 I1 and 10 ohm it will be 10 into I2 plus I1. Agreed? So V2
Yes.
will be 3 into I2 minus 2I1 plus 10 into I1 plus I2. So that will be minus 6I1 plus 3I2 plus 10I1 plus 10I2. So 4I1 plus 13I2. That is V2. So this will be 10I1 plus 10I2 for V1. So V1, V2 will be, what will be set parameters? Here set 1, 1, what is that? From the equations 1 and 2. What should be the set matrix?
10, 10, 10, 10, 4, 13.
10, 10, 4, 30, I1. So you will have set 1, 1 as 10, set 1, 2 as 10, set 2, 1 as 4, and set 2, 2 as 13. Write with units, ohms. Five to 8, I think, if I am right. Yeah, 5 to 8, it's the admittance parameters. So this is a given two-port network. You are asked to calculate the Y parameters. So Y parameters, actually what we need is I1, I2. We should get in terms of V1 and V2. So maybe this node we can take. This is V1 as such. This node, it is voltage across 1 ohm, so that is V1. So this nodal voltage we can take it as V1. Similarly here this nodal voltage we can take it as V2. Let me name this node voltage some Vx or whatever, just to distinguish. Okay, so now with this, if you apply KVL at node 1, or sorry, not KVL, KCL, nodal analysis at node 1, how do you get? I1 is entering the node 1, then this is the reference. So I1 is entering the node, the current flowing through 1 ohm, we assume that to be leaving. So this is leaving. Similarly, V1 minus Vx by 1. So tell me, V1 by 1 plus V1 minus Vx by 1 equal to I1. These two are the leaving currents. This is the entering current. Is it okay?
Ma'am, please show 1 second, ma'am. How?
I1 is you are applying KCL at node 1, where the node voltage is labeled as V1. Here, this node, I1 current is entering the node. Then if you go back to what you have learnt in ESTC, conventionally we assume that at the node, we unless if it is a current source or predefined directions, we assume the currents flowing through the branches as leaving away from the node when we apply KCL at node. Okay, so I'm assuming through this 1 ohm resistor, the current flowing to be leaving away from node 1. Similarly, the current flowing through this 1 ohm also I assume to be leaving away from node 1, so that the current flowing through this 1 ohm, by assuming it to be leaving away from the node, I can write the expression for that current as V1. Here is this potential minus the other node is the reference node, which is at ground, 0 volt. So V1 minus 0 by 1, so V1 by 1. Similarly, this is V1 minus Vx by 1. So V1 by 1 and V1 minus Vx by 1 are leaving currents. So sum of leaving currents. Other one is I1, which is entering the node. So equal to the entering current. So I will get this equation, which is the KCL at node 1. Okay.
Yes.
Simple KCL. Similarly, if you apply KCL at node 2, did I write it? Applying KCL? No. Okay. How do you get a KCL at node 2? V2 by 1 plus V2 minus Vx by 1 equal to I2. So what we have is I1 equal to, here it is 2V1, 2V1 minus Vx. Here it is I2 equal to 2V2 minus Vx. Now, if you apply KCL at node X, where the nodal voltage Vx is being marked, so KCL at X. What do we get? Vx minus V1 by 1 plus Vx minus V2 by 1 plus 2v1 equal to 0. So what we get is 2vx plus 2v1 minus v1, so plus v1 minus v2 equal to 0. So vx equal to v1 minus v2 by 2. Vx equal to v2 minus v1 by 2. v2 minus v1 by 2. So substituting vx
Ma'am, I'll have to leave the session today a bit early.
Yes, sir.
I'll have to leave the session today for some work.
Yeah, fine. You can carry on, sir.
Thank you, ma'am.
Yeah. Hemant, so substituting Vx, what do you get for I1?
Yes, ma'am. Check, ma'am.
I1 equal to 2v1 minus Vx. So 2v1 minus v2 minus v1 by 2. So we will in effect pi by 2 v1 minus v2 by 2. I2, what do you get? I2 was 2v2 minus vx. So 2v2 minus vx. So it is v1 by 2 plus 5 by 2 v2. Sorry, plus 3 by 2 v2. So comparing this with the standard matrix form. So y11 will be what?
Five by two
Yes, 5 by 2
minus half,
minus half,
half,
half, and
3
3
by
by
2.
2. Shall we move on to the next question?
Yes, ma'am.
So this is 9 to 13, 12, I think. Yes. Here also we are asked to calculate the set parameters. So here one easy way of doing, can you just find it out? If you see the circuit, observe the circuit. Since with the given circuit, we have one provision of doing it in a much easier way. What's that?
Easier, no, ma'am.
Yeah, just observe the circuit. You have all the resistors as 1 ohm, and also the see the configuration. I mean the connection of the resistors in the given circuit, and just think all of them are of equal value. So better way of alternately uh, transforming this circuit with what you have learned so far. Can you just try to find out something?
Please give more hint, ma'am.
What is this?
1 ohm in series with V1 voltage
What is
source.
this? How they are connected?
Oh, this is pi
Pi, delta, right?
delta connection. Yes, ma'am.
All of them are equal value. Shall we transform it into star or T network?
Yes, yes, ma'am.
What will be the value in the corresponding star?
I think delta by 3.
Yes. So let me just mark it. So now this 1 by 3 and 1 again can be plugged into a single resistor. So that will be so what we write here V1 in terms of I1, I2. The standard matrix form will be V1, V2 will be set parameter set matrix into I matrix. So how do we write V1 in terms of this one? You can apply KVL here. What do you get?
V1 equal to V1 equal to
What is the current
I1
flowing
with
through one this 1 by 3?
I1 plus I2.
I1 plus I2. With that you can apply KVL here. Right? So loop 1 and loop 2. So applying KVL in loop 1. That will be V1 equal to 1 by 3 I1 plus 1 by 3 into I1 plus I2. Applying KVL in loop 2. V2 will be 4 by 3 I2 plus 1 by 3 I1 plus I2. So this will be 2 by 3 I1 plus 1 by 3 I2. This will be 1 by 3 I1 plus 7 by 3 I2. Sorry, for 1 by 3, right? So for 5 by 3. 5 by 3 I2, not 7 by 3. So Z11 will be 2 by 3. Z12 is 1 by 3. Z21 is 1 by 3. Z22 is 5 by 3.
Yes, ma'am.
So next question. So that is also a simple T network. Ten ohm, 15 ohm, and 5 ohm. So directly tell me V1 will be 10 I1 plus 5 into I1 plus I2. V2 will be 15 I2 plus 5 into I1 plus I2. So that will be 15 I1 plus 5 I2. This will be 5 I1 plus 20 I2. So Z11 will be 15, Z12 will be 5, Z21 will be 5, Z22 will be 20. What's the question? 17. Okay. This is the circuit. Tell me the KVL. Sorry, KCL at node 1.
I1 equal to x minus y by 2 plus x by 1.
Vx by 1 ohm plus Vx minus V by 2. So I1 will be Vx into 1 plus 1 by 2. right? So 3 by 2 minus V by into half. Here Vx is nothing but V1. So we directly better write it as V1 and V2. So V1, V2. Let me take it as node 1. So V1 by 1 plus V1 minus V2 by 2. So V1 into 3 by 2 minus V2 into half. Similarly, what do you get at 2? I2 equal to 3I1 plus V2 minus V1 by 2. So I2 equal to 3 into 3 by 2 V1 minus V2 by 2 plus V2 minus V1 the whole by 2. So that you will get it as V1 into minus 1 plus 9 by 2 plus V2 into 1 by 2 minus 3 by 2.
I2 equal to 4V1 minus V2, no, ma'am?
Actually, what are the parameters being asked? I have to find out. Is it Y or Z? Yeah, Z. Z parameters are being asked. So we actually want V1 in terms of the other way out. Okay, okay, fine. So what are being asked is set parameters. So find out V1 in terms of V1 and V2 in terms of I1 and I2. What do we get? How do we write V1 and V2 in terms of I1 and I2?
Ma'am, here V1 equal to I1, ma'am. I1 into 1 ohm, that is I1.
Okay.
Similarly, V2 equal to 3I1 is going, no, ma'am? Just
But how do you say that I1 is flowing through this 1 ohm? I1 alone.
Yes, ma'am. Yes, ma'am. Because some part of current will flow through 2 ohm
Ah,
also.
ah.
So by applying KVL, ma'am, can we apply KVL, KCL, KCL?
Yeah, you can apply KVL. If you apply KVL, what do you get? V2, V1 plus V1 minus V2. Okay, so then we have to go with the basic definition. So we can open circuit the this one. We can make I1 as 0. Okay.
What,
So
ma'am?
when I1 is 0, the dependent current source becomes 0 because it is 3 I1. So let me just run this because I was trying to calculate the Y parameters. So what do you have is V2 will be 2 plus 1 into I2 implies V2 by I2 equal to 3 ohm. That will be your set 2 book. V1 will be I2 into 1 ohm. implies V1 by I2 equal to 1 ohm. So that is Z12. Now you open circuit the other port. This is open circuiting the input port.
Ma'am, please once again explain.
One second. So here I am open. This is let me label it as 1 dash, the port 1. This is 2 dash, the terminals port 2. Okay. So we are trying to find out first open circuiting the port 1. That means I1 current is 0. Then when I1 is 0, we can find out, we open circuit this port and we find out the parameter. Similarly,
When
when
here open circuit means where it is open, ma'am, please.
means this current I1, we are making it 0. Similarly, towards this side, the current entering from the port 2, which is I2, we are open circuiting that. I2, we are making it 0. So when we make I1 as 0, then this dependent source, which is 3I1, becomes 0. That's why I have replaced it here by shown it here by open circuited. Then this will be simply this I2 will flow through this 2 and 1 ohm as such, 2 and 1 ohm in series. That's why I've written here this V2 will be 2 plus 1 into I2. So I will get V2 by I2, which is nothing but set to 2. Similarly, V1 will be what? V1 will be what is the current flowing through this 1 ohm? I2. So I2 into 1. So between V1 and I2, that will be set 1 2.
And
So set
V1,
1 2. Set 1 2, we will get it as 1 ohm.
V1 equal, please, ma'am.
V1 is V1 is across 1 ohm, right? Voltage across 1 ohm. What is the current flowing through 1 ohm? I1 is 0. From this side, I2 is flowing. We just now in the previous equation for V2 we have written I2 is the current flowing through 2 ohm as well as 1 ohm. Because at this node, it will not split as any other current here because this is 0. So 2 ohm and 1 ohm in series. So what is in effect the current flowing through 1 ohm, which is I2. So the I2 into 1 ohm will be the voltage across 1 ohm, which is nothing but V1. So V1 I can write it as I2 into 1 ohm. So that V1 by I2 ratio will give you Z. What is that Z? 1 1 or 1 2 or 2 1 or 2 2? It is between V1 and I2. So that will be Z 1 2, which is 1 ohm. Fine.
Yes, ma'am.
Similarly, we open circuit the other port. Port 2 is open circuited, so I2 is 0. So what do we get? The corresponding circuit will be 1 ohm, 2 ohm. Here we had that dependent source across which we have V2. So KCL at 1, what do you get? I1 equal to V1 by 1 ohm plus 3I1. Then what do you have? minus 2I1 equal to V1. Correct? I1 is applying KCL at this node. Okay, I1 is entering, that will be V1 by 1 ohm plus this 3I1. So I1 minus 3I1, so that will be minus 2I1 equal to V1. Okay, so
Yes.
what will be V1 by I1? That will be said 1 1, that will be equal to minus 2. Then what else is left out? Said 1 1 2, said 2 2, said 1 1. So set 2 1. In order to find out set 2 1, we want V2 by I1. For that, you can apply KVL here, right? What do you get?
Is uh, 1 into 2I1.
We get this is V1, right? Across 1 ohm is V1. What is the voltage
Yes.
across 2 ohm? What is the current flowing through 2 ohm?
3I1.
So 6I1. So minus V1 plus 6I1 plus V2 equal to 0. And we have for V1 here, we have V1 as minus 2I1. So minus of minus 2I1 plus 6I1 plus V2 equal to 0. So 2I1 plus 6I1 plus V2 equal to 0. V2 by I1 equal to minus 8, which is said to 1. So said 1 1 will be minus 2, said 1 2 is 1, okay.
Please explain once again the equation, ma'am. Final equation
Which
after
one?
KVL. After
You
applying
got this.
KVL,
You got this equation minus V1 plus 6I1 plus V2 is 0.
how, ma'am? Minus V1, okay.
See here.
After that,
See here.
6.
I have shown here the KVL green color. This is say you come start from this node. Okay. So what is the current flowing through this 2 ohm? 3I1. So drop across 2 will be 2 into 3I1. So that will be 6I1. What is the voltage across this source? V2. So 6I1 plus V2 minus V1 equal to 0. That is this equation. 6I1 plus V2 minus V1 equal to 0. Okay.
Yes.
Then from this equation, V1 is minus 2I1 because we are right now finding out set 2 1, which is V2 by I1. So we are trying to write V1 in terms of I1. So from this equation, V1 is minus 2I1. So for the in this equation, I have substituted V1 as minus 2I1, and then I have found out the ratio V2 by I1, which is nothing but set 2 1. Other three parameters we have already found out. So these are the set parameters for the given circuit. Clear?
Yes, ma'am.
Okay. So these were question numbers till 20. T1. They're asked to calculate find y1, y11.
I1 by V1.
How much?
That is equal to I1 by V1, no, ma'am?
I1 by V1. Yes. So y11 is I1 by V1 at V2 equal to 0. So our equivalent will be 10 parallel 10 plus 5, that will be parallel to 10. So that will be what, 10 and 10 parallel 5, 5 plus 5 10, 10 parallel 10. So that will be 5 ohm. So in effect what we have is 5 ohm 1 1 dash I1 V1. So V1 is 5 I1. So I1 by V1 is 1 by 5, which is 0.2 whole inverse. Next question. This question number 21. Okay. You're asked to calculate the set parameters. So what will be V1 will be 10 I1 plus 20 into I1 plus I2. V2 will be 20 into I1 plus I2. So that will be 30 I1 plus 20 I2. This will be 20 I1 plus 20 I2. So set 1 will be 30. Okay.
Yes, ma'am.
Now let me see what is question number 26. So 26 maybe we can do it CAC. We have to just see the impedance. So that is one example shown to you through practice for the CAC. Then what else? 27 and 28, two more on two-port network parameters. After that we have the questions on this mutual inductance transformer as two-port network. So maybe I think from 26 we can do it tomorrow. Fine. So maybe three more questions on two-port networks, after which we will discuss the transformer as two-port network, that mutual inductance, all those things with that dot convention, whether the flux is additive or opposing, all those things. And then we will solve the questions on those also. With that, we can wind up tomorrow. So shall we stop it here?
Yes, ma'am. Ma'am, concept will be discussed tomorrow or today, ma'am? Concepts, remaining concepts of week 11.
Tomorrow, because we have two more on this two core networks, solving which we will go through the concepts on the transformer as two core network. After that, some 4 or 5 problems on those from the practice.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
So, are you in parallel preparing for the other weeks already passed for the end semester?
No, revision not yet started, ma'am. What shall I do, sir? Revision we will start, ma'am.
No, no. Revision session we will start once we complete week 12. Already mentioned in the beginning of the session, right? We will be
Yes,
starting
ma'am.
with week 12 this Thursday, and
Mhm.
the second session on week 12 will be on Monday, and that Tuesday onwards we can have the revision session. So maybe
Ye-
by this Thursday, Monday, I will let you know the exact schedule for the revision session. So during the
Yes,
revision session, I plan to go through both the concepts as well as numericals on the on each week. So during that numerical solving, we will be doing not with the what practice and graded already being done in the session, and detailed solutions are also at the time released to you, so that you have to go through again. So maybe additional tutorial questions like from the diodes or from BJT or from whatever the corresponding week's topics we can do on numericals. Then a brush up on all the concepts as well, the lecture topics covered for every week. That also we can do. So that we have to split week wise the revision sessions.
yes,
Okay.
ma'am.
So that exact schedule, whether we start with week 1 and go till week 12, or the reverse, that I will plan and then let you know by Monday, or Monday also I will let you know. Okay.
Yes, ma'am.
So request you to prepare in parallel, revise in parallel, so that things will be easier for you for the end semester.
Yes, ma'am.
And I couldn't release the week 9 graded solution set. I will do it shortly. Okay,
Yes, ma'am.
fine. So see you tomorrow, 7 to 9 p.m.
Okay, ma'am. Thank you,
Yeah,
ma'am.
thank you.